Hi, welcome to the video solution for Edexcel Physics. This is IAL Physics Unit 4, Part 1, Summer 2018. Let's start. Question number 1. The isotope polonium 84209 decays by emitting an alpha particle. So we have decay process by alpha particle. Which of the following correctly shows nucleon in the isotopes produced? So we are given option 123 neutron, proton. Okay, so what happened when some nucleus like X having charge number Z and mass number A? If this nucleus undergoes decaying process of alpha particle, alpha is 2, 4, the new nucleus has a charge number decreased by 2, Z minus 2, and the mass number decreased by 4. So this is general concept of alpha particle decay. So charge number is decreased by 2 and mass number decreased by 4. Originally charge number was 84. So it should be decreased by 2. So the new charge number or new nucleon number, not nucleon, proton number should be 82. So that means we cannot have option B and D. So these two options are gone. So we need to choose either A or either C. But remember, they are not asking about the nucleon number or mass number. Instead, they are talking about neutrons. So first you need to figure out how many neutrons are there. So number of neutron n is 209 minus 84. That means initially polonium had 125 neutrons, and when alpha particle emits, along with alpha particle, in alpha particle we have two neutrons and 2 protons. That means by emission of alpha particle, out of 125, 2 neutrons are gone, so remaining are 123. That means option is A. Question number 2. Two objects collide and rebound. Select the row of the table that is correct for the total momentum and total kinetic energy of the object in an inelastic collision. Remember, no matter what type of collision we have, momentum always remains conserved. So we cannot have option C and D. We need to choose either A or B, because in both we have a conserved momentum. The only thing we need to decide about the kinetic energy, and they are talking about inelastic collision, where the kinetic energy changes or does not remain conserved, either increase or decrease. So option is B. Question number 3. The potential difference V is applied across two identical capacitors of capacitance C connected in parallel. Which of the following expression gives the total energy stored on the capacitors? Remember, if you have a single capacitor, C is the capacitance, so energy stored is half of CV squared. This is energy stored in one capacitor. But if you connect two capacitors in parallel, then the total capacitance or net capacitance is sum of the individual ones. The capacitance is increased. In this case, we are using two identical capacitors of capacitances C in parallel, then the total capacitance would be twice of the previous one. So if you replace the total capacitance is 2C, that means the energy will be half of 2C into V square, and 2 gets cancelled, so CV square. That means option is C. Question number 4 and 5 refer to the following situation. The diagram shows an electron deflection tube, filament anode electron gun. This is deflection path of a charged particle. Electrons are released by a filament and accelerated towards the anode, producing a beam of magnetic field is applied, deflecting the beam as shown. Which of the following causes electron to be released from filament lamp? A typical question, releasing electron from a filament, it's all about heating effect. That means thermionic emission. Option is D. Question number 5 from the same situation. In which direction is the magnetic field applied to the result in the deflection shown? Okay, in these types of question, we use Fleming left-hand rule, and remember, Fleming left-hand rule is we use for motion of positive charge. So assume if this charge particle were positive charge, then we can assume that the positive charge path should be moving something like this. This is a motion supposed to be for a positive charge supposed to be going that direction. So now you can apply left-hand Fleming rule. So you put your second finger in that direction and thumb downward, and then clearly you can find your first finger, which is the direction of the field from your left hand. It will be out of the page. It will be out of the page. I would recommend that you set your left hand finger, this is your second finger, in that direction, because charged particle is moving that, and the positive charge is supposed to move down, so thumb should be down. Then you will see that your first finger, which is the direction of the field, is towards you or out of the page. So option is D. Question number 6. Which of the following decays for pine would not be possible? Okay, here pi 0, 2 gamma, so charges are conserved. So lepton number and some other baryon numbers are also conserved. So this is possible. Pi plus E plus, this is also possible because you have a charge conserved and you have a lepton number conserved. This is antiparticle. This is anti-electron, and this is electron neutrino. So yes, B is possible. Pi 0. So see, if you see here in C, pine has a 0 charge, anti-electron, which is a positive. So charges are not conserved. Charges are not conserved. Even anti-electron neutrino cannot comes along with anti-electron. So we have two reasons to choose C. Number 1, charges are not conserved before or after, and positron cannot comes along with anti-electron neutrino. It should comes with electron neutrino. So option should be C. Let's check for D. 0, E plus E minus, of course, charges are conserved. Lepton numbers also conserved. So D is possible, A and B are also possible. So C is not possible decay for pine. So option is C. Question number 7. The table shows 6 types of quark and their relative charges. U, C, T 2/3, D, S, B minus 1/3. Which of the following shows a possible quark composition for a baryon with charge minus E? Minus E, or you can say minus 1 is fine. So charge per E, yeah, in E. So that means this is 2/3 of E, this is minus 1/3 of E. Okay, for each quark. Now clearly you can check the charges one by one. Like I just give you example, C, C and S bar. So C means 2/3 of E, plus 2/3 of E, C and C, and S bar or anti-strange has a plus 1/3 E. Clearly you have a positive number. You have a positive number. That means your charge would be 5E by 3. You cannot have, you need charges minus E. It is 5E, positive 5E by 3. And clearly U bar, and B. So once you do for all, you will find that, I guess, DSS. Yes, I guess, check this one, DSS. D is minus 1/3 E, S and S, minus 1/3 E, minus 1/3 of E. So finally you have answer minus 3/3E, that means minus E. So your option is B, and you can check for C and D to just verify. You cannot have a minus E any other option. So option is B. Question number 8. Two identical point charges Q1 and Q2 are placed a small distance apart. The force acting on a Q1 has magnitude F. The charges Q and the distance between the charges are both doubled. The charge Q is unchanged. What is the magnitude of the new force on Q1? So you have two charges, Q1 and Q2, and they are some distance r apart, and we know that the force between two charges F is equal to K Q1 Q2 over r square. They are saying amount of charge and the distance both are double. So that means the Q1 will be twice of the Q1 and r will be double. That means 2r square. It will be 4r squared. So this 2 will cancel this 4 in denominator. So you have 1/2. That means your option is C. The force will be half. Question number 9. A magnet is pushed through a coil of wire at a steady speed, inducing an EMF. Okay, in the coil. The following graph shows how epsilon varies with the time. So this is producing induced EMF when a magnet passes through a coil, and the magnet is then pushed through in the same direction at a higher speed. Which of the following shows a graph of E against T for higher speed? So higher speed means rate of change of flux. Rate of change of flux will be higher. So flux is going to change with the higher rate. That means the producing EMF should be higher. So the peak value must be greater than the previous one, even because high speed, so it will take less time to produce this pattern. So in this case your option should be B. We cannot have option A because we have a smaller time but same amount of peak. We cannot have option C because higher peak value, it is fine, but time is almost same. So we cannot have C. Even we cannot have D because we have a large amount of time and even a smaller peak. So if you see, B is higher peak and less amount of time. So your option is B. Question number 10. Two conducting plates are 5 centimeters apart. The potential difference between the plates is 10 volt as shown. Okay. Which diagram correctly shows the electric field between the plate? clearly we can ignore A and C. The reason is because we have a high potential upper plate and the low potential lower plate, so electric field between the plates should be from high potential to low potential. So the arrow for the electric field should be downward, not the upward. That's why we immediately cancel A and C. Now we need to decide B and D, electric field. So now we need to decide on the basis of this magnitude. So between the two plate electric field, E is V upon D. V is 10 divided by D. D is 5 centimeter. This centimeter should be converted into meter, and if you do that, so 5 divided by 100, that means 0.05. So E would be equal to 200 Newton Coulomb inverse or volt per meter. So option is D. This is your option. Question number 11. An electron travels through a uniform electric field for a time of 4.3 into 10 to the power minus 9 seconds. It is deviated from its original path as shown. Okay. Calculate the deflection Y of the electron. Electric field strength is 1.3 10 to the power 4 Newton per Coulomb. Okay, so we need to find this distance, this deflection. Okay, this is the deflection we need to figure out. And if you see, before entering into the field, we don't have any vertical motion. So that means as soon as electron enters into the field, it starts accelerating. Before the field, it was not accelerating, it is moving with uniform velocity horizontally, but as soon as the electron enters into the field, it starts accelerating downward. That means for Y we need to use accelerated motion concept. That means we are going to use S is equal to ut plus half at square, because time is given, so we can use this time in our equation, and S is a vertical distance, which is I can replace S with the Y, and U, before entering the field we don't have any vertical velocity, so U is 0. That means I have half of at square. I have time, but I don't have acceleration. That's what I need to find. Acceleration. Once if I'm able to find the acceleration, I can figure out value of the Y. So for the acceleration, I'm going to use concept of electric field, and electric field E is force per unit charge. Force per unit charge, and in this case charge is electron, so F is equal F upon E. That means F is equal to E times E. E is capital E is electric field, small e is charge of electron, one electron, and F is MA equal E into E. Clearly A can be found, A is equal to E upon M. E is given 1.3 10 to the power 4. E is charge of electron. If you remember, that's good. If you don't remember, you can see your data sheet, and M is mass of electron. So you can put the numbers 1.3 into 10 to the power 4. Charge of electron 1.6 into 10 to the power minus 19 Coulomb divided by mass of electron 9.11 into 10 to the power minus 31 kilogram. And now you can have your acceleration, which is around 2.3 or accurately 2.28 or 2.3 into 10 to the power 15 meter second minus 2. This is your acceleration. Now you can figure out Y. So your Y would be equal to, Y is half of acceleration, which is 2.28 or 2.3 into 10 to the power 15 into t square. T square is 4.3 into 10 to the power minus 9 whole squared, and y equals 0.021 meter. This is your vertical deflection. Thank you very much for this video. Have a nice time. See you in the next one.